Hello students, in the last class we were discussing about some of the important concepts of electromagnetic radiations and related to that of the characteristics of electromagnetic radiations and how the behavior of electromagnetic radiation, that is generally electrical and magnetic waves which propagates in a perpendicular direction, that also we have seen. Along with that, black body radiations also we have seen, and similarly the Planck's quantum theory also, that has been explained in the previous class. Along with that, one important 3 or 2 marks question also explained, that is a photoelectric effect. Along with that, the threshold frequency is the minimum frequency of radiation which helps to remove the electron from the metal surface. So that also we have seen. That might go for again for 1 marks, right? So that's all we have studied in the previous class. But in today's class we'll study about some of the important concepts like dual nature of electromagnetic radiations and why it is called as a dual nature and what is the exact meaning of dual nature, that we'll see in the today's classes, right? So as we go here, in case of dual nature, dual, the word itself says dual means it is two, right? So dual means two. So there are two different natures for the electromagnetic radiations, right? So those two important natures of electromagnetic radiations are, one is particle nature, another one is called as wave nature, right? So which means the light radiations can be present, or the electromagnetic radiations can be present in two different forms. So in that, first important thing is it can be present in the particle nature and it can be present in the wave nature, which means the electromagnetic radiations can propagate so in the form of particles also, and similarly in case of wave also. That is generally called as a dual nature of electromagnetic radiation. So whenever the radiations interact with matter, right, so it shows a particle nature, right, which means whenever the radiations interacts with any kind of matter or any kind of substance, so it shows the particle nature, and whenever the light propagates in the form of waves, it shows the wave nature. So it's very simple to understand. So if there is a light radiation, if there is any material, so take any kind of material, so if the light radiation falls on this, right, so it shows the particle nature. The light radiations shows the particle nature, right? So but we also studied that so this is a particle nature of light, right? So and also we have studied that the light radiations can propagate in the form of wave also, can also propagate in the form of wave. So that is generally called as wave nature. So and the combined form of this particle nature as well as wave nature is generally called as dual nature, right? That is generally called as dual nature of light. So therefore, so light has capability of transferring or transforming in, or the movement which takes place in the cases of both types. So one is particle nature and second one is wave nature. And there are various theories which explains the light can be traveled in the form of the small energy packets or in the form of particles. So those were generally called as a black body radiations, and Planck's quantum theory also explained the light can move in the form of particles also. And also the photoelectric effect, here there is an emission of electron, what we have seen in case of photoelectric effect, that also basically explains so that so the radiations so which are in the form of particles can be observed in case of any kind of propagation of electromagnetic waves, right? And also the wave nature is explained with the help of interference and diffraction. So whenever you study in case of physics concept, the interference, diffraction, right, so those concepts are very important to explain the electromagnetic radiations can transfer or they can move in the form of wave also. That only, as I explained, whenever it strikes on the surface of any material, so the light radiations or the electromagnetic radiations behaves as a particle nature, and whenever they propagate in the form of wave, that is generally called as wave nature. And both combined form of the particle nature and wave nature is generally called as dual nature of, right? So that is called as dual nature of light radiation or electromagnetic radiations. Okay, the another important concept in case of the study of electromagnetic radiation is a spectrum, right? So as you studied in the lower classes also, spectrum means whenever the white light is passed through the prism, it splits into series of color bands, which means they can be splitted into different colors, as we seen in case of the radiations, that is visible radiations, which are present in the range of 400 nanometer to 750 nanometer. Whenever they strikes on the prism or any kind of glass surface, they can split into various different wavelengths based on the different range of their nanometer. They can be split into 7 different colors that we have seen, that is violet, indigo, blue, green, yellow, orange, red. So that is nothing but it is known as spectrum, right? So whenever the light, white color light passes through the any kind of prism, right? So if you take this as a prism, so if there is an incoming radiation which strikes on the surface of this prism, so this is divided into 7 different colors, as you said that one, right? So these 7 radiations are violet, indigo, blue, green, yellow, orange, red, right? So this is generally called as a spectrum. Spectrum means that is a splitting of white light. So this is generally a white light. So this white light, whenever it strikes on the surface of this prism, right? So this is a prism, right? So whenever it strikes on the surface of prism, so it divides into different radiations based on their wavelength, because white light can be present at the range of 400 nanometer to it can be present at 750 nanometer, which means from 400 to 750, so the light radiation is divided into 7 different colors, right? So like this, whenever it divided into 7 different colors based on their wavelength, right? So which is given in terms of nanometer. So these are arranged in a particular order, that is it is splitted into different kinds of radiation, that is violet, indigo, blue, green, yellow, orange, as well as red. And this splitting of light, so this phenomena is generally called as spectrum. Remember, whenever the white light strikes on the surface of prism, so this prism has capacity to split that light radiations into 7 different colors, and these 7 colors are arranged in a particular order, that is violet, indigo, blue, green, yellow, orange, red. Generally we'll call it as VIBGYOR. And this phenomena of splitting of light radiation, that only I have written in here definition for. Whenever the white light is passed through the prism, it splits, right? So it splits into the series of colored bands, which are generally known as spectrum. And there are 2 different types of spectrum. If you divide the spectrum, so there are generally 2 sub types of spectrum. One is continuous emission spectrum, and second one is line emission spectrum. We'll call it as continuous spectrum as well as line spectrum, right? So what is the exact meaning of emission spectrum, right? So emission spectrum means the spectrum of radiations which are emitted by the substance that has absorbed energies, right? So the spectrum of radiations, which means here the radiations, if you observe these radiations, right? So these radiations are emitted by the substance so that has absorbed energies. The energies which are absorbed by those radiations are generally called as emission spectrum, right? So whenever there is a substance, so right, if you take any kind of material, so whenever the light radiation falls on this, so this has capability to absorb some amount of radiations, right? So after this absorption of the radiation, so it will release some amount of radiations, or it will emit. So it will emit some amount of radiations. This emitted radiations is generally called as emission spectrum, right? So the spectrum which is obtained due to the emission of radiation after absorption of some amount of energy from the, so that is interacted light radiation, some amount of energy from the interacted light radiations, that emitted radiations is generally called as emission spectrum. The spectrum obtained due to the absorption of the light radiation which strikes on the surface of the substance, that is generally called as emission spectrum. And absorption spectrum is the spectrum obtained when the radiation is passed through a simple material, the sample absorption of radiations in the certain wavelength, right? So the only one difference is emission. What happens? So the light radiations emits, and in case of absorption, the spectrum which is obtained due to the absorption, right? So in emission, what happens? So the spectrum obtained due to the emission of radiation is called as emission spectrum, and spectrum obtained due to the absorption, right? So due to the absorption is generally called as absorption spectrum. There are only 2 types of spectrum. One is emission spectrum, right? So and absorption spectrum. Right, so the word itself says the emission spectrum means the spectrum obtained due to the emission of light radiation after absorption, and the radiations or the spectrum which are obtained after due to the absorption of light radiation is generally called as absorption spectrum. Right, the study of emission and absorption spectra is generally called as a spectroscopy. The spectroscopy is a branch of chemistry, so that is generally called as spectroscopy. That is a branch of chemistry which deals with the study of the emission spectrum as well as absorption spectrum, right? So whenever if you study the emission as well as the absorption spectrum, so that is generally referred as a spectroscopy. Spectroscopy is generally is a branch of chemistry which deals with the study of emission or absorption spectra, right? So once again we'll see the spectrum means whenever the white light passes through the prism, it splits into different colored bands. That also I have explained here. Whenever it strikes on the surface of the prism, the white light splits into 7 different wavelengths or 7 different colors. They are arranged on the order of they are arranged on the order of their wavelengths, that is from 400 nanometer to 750 nanometer. Therefore, these radiations are generally called as a spectrum. That is the splitting of white light into different colors. Whenever it strikes on the surface of the prism is called as spectrum. And if you go for the sub-classifications of spectrum, the spectrum is divided into 2 classification. One is continuous emission spectrum, second one is a line emission spectrum. In continuous emission or in case of emission spectrum, what happens? The spectrum of radiation emitted by the substance that absorbed energy, right? So that has already absorbed energy is called as emission spectrum. But in case of absorption spectrum, what happens? The spectrum obtained when the radiation passed through the simple material or the sample of the material, that sample absorption of the radiations of certain wavelength, right? So that material has capacity to absorb, because whenever the light radiations passes or strikes on the surface of the material, not all the radiations, there is 100% transference is highly impossible. At least some amount of energy is absorbed by those molecules, or at least some amount of radiations are absorbed at particular point. So due to that, the spectrum is obtained. There is splitting of different kinds of radiations obtained. So that is generally called as absorption spectrum. And the overall study of this emission as well as absorption spectra is generally called as spectroscopy. Therefore, we'll call it as the branch of chemistry which deals with the complete study of emission and absorption spectra is generally referred as a spectroscopy. So particularly if you go for the spectral lines of atomic hydrogen, if you take atomic hydrogen, so whenever the light radiation pass through that atomic hydrogen, so what kind of changes can be obtained in that, right? So that can be studied under the spectral lines for atomic hydrogen, right? So there are 5 different spectral lines for the atomic hydrogen. I have represented here in the column wise. So in the first column it is a series. So there are different names for the series, and the second column there is a N1 value, and third column it is a N2 value, and fourth column or in the last column there is a spectral region. What is the spectral region in which the different series can be obtained or different series can be observed, right? So here there are 5 different series for hydrogen. There is atomic hydrogen. One is a Lehman, that is named after, all the things are named after the discovered by the particular scientist, right? So Lehman series, Balmer series, Paschen series, and bracket series, as well as Fund series, right? So you can call it as P Fund series, or you can call it as simply Fund series, right? Lehman series, Balmer series, Paschen series, bracket series, and Fund series, right? So in Lehman series, the N1 value will be 1, and N2 value will be next to that value 2, 3, 4. And Lehman series generally obtained in case of ultraviolet region, right? So Lehman series generally obtained in case of ultraviolet region, right? And similarly Balmer series. So Balmer series, what happens here? The N1 value is 2 and N2 is 3, 4, 5. The next to that one 3, 4, 5, and the spectral region is visible region. And the Paschen series, bracket series, and Fund series can be obtained in case of infrared region, right? So understand here there are 5 different types of series which can be obtained in case of atomic hydrogen. So which means whenever the hydrogen the light radiations falls on the surface of the hydrogen atom, so it has capability to produce 5 different series. First one is Lehman's, and second one is Balmer's, third one is Paschen, and fourth one is bracket, and fifth one is Fund series. In Lehman series, what happens? The N1 value is 1, N2 value is 2, 3, 4, like this. And the region which is obtained here in case of a Lehman series, that is in the ultraviolet region. And in case of Balmer, what happens? So it is obtained in case of visible region, and in Paschen it is generally obtained in case of infrared. In bracket also it is obtained in case of infrared, and in case of Fund series also it is obtained in case of infrared, right? This can be asked for 2 marks. Explain the different types of spectral lines in case of atomic hydrogen. Most of the time it is repeated. You must draw this column wise. That is the series in the first column. Second column it is the N1 value. Third column it is the N2 value. That is an next excited states. And the fourth column is the region in which the spectral lines or the series can be obtained. Always remember, Lehman at the ultraviolet region is obtained, and the Balmer series can be seen. The only Balmer series can be seen in case of visible region. So and all the other three, Paschen series, bracket series and Fund series, can be obtained in case of infrared radiations. So here if you want to see the atomic hydrogen atom, how the different series are obtained. So if I take the continuous energy levels, right? So that is E0, that is E1, right? That is E2, similarly E3 and E4 as well as E5, right? So these are the energy levels, right? So here what happens, the electrons which can jump from higher energy level to, right? So the first energy level, right? So 1 to 0, right? So 2 to 0, 3 to 0 and 4 to 0, right? So this is 4 to 0 and this one is 5 to 0, right? So this type of arrangement is generally can be seen in case of a bomber, right? So that means this is 1. So here, which means the N1 value will be 1 and the N2 can be so 2, 3, 4 and continuously so on, right? Similarly in case of bombers, so you have observed this one, and even in case of Paschen series, that is second one, right? So the electron jumps to the second because N2 value, the first value is N1, that is equal to 2 and N2 is equal to 3, 4, 5, right? So this is called as a Paschen series. Similarly in case of bracket series, so that is you can observe like this, right? So higher energy level to this one, that is the third energy level, that is N1 might be 3 and N2 might be 4, 5, 6, like this. The different kinds of radiations are particularly arranged so in terms of different kinds of wavelengths, and these are the some of the excitations of energy levels. The electron can jump from one energy level to another energy based on their different series, right? So therefore the Balmer series, which is obtained in case of the ultraviolet region, and other three, the last three are obtained in case of the infrared region also. And here one of the important thing which you have to study in case of this hydrogen spectrum, that is Rydberg's equation, right? So Rydberg is the name of scientist. He gave one equation. You will get one problem from this equation, that is nu bar, wave number is equal to, so 109677, that is a constant value, that is generally called as R, that is R into 1 by N2 square minus 1 by 1 by N1 square minus 1 by N2 square, that is nu bar is equal to 109677. So that is 1 by N1 square minus 1 by N2 square per centimeter, right? So it is measured in the units of per centimeter, right? So here this R represents the Rydberg constant value, right? And that Rydberg constant value is 109677. There is a constant value 109677 per centimeter, right? So there will be a 1-2 marks question. There might be a 1-2 marks question from this formula, that is calculate the wave number, because nu bar represents the wave number. So nu bar is equal to R into, right? So this is generally can be written in the form of nu bar is equal to R into 1 divided by N1 square minus 1 divided by N2 square per centimeter, right? So wherever R is there, so that is the Rydberg constant value, right? So that is known as the Rydberg constant value, and the value of that Rydberg constant is 109677 per centimeter, right? So further at the end of this chapter we'll solve the problems on this formula, that is calculation of wave number for the given radiations of atomic hydrogen atom, or different kinds of atoms can also be seen. And next important thing in the study of the structure of atoms, that is a Bose model of hydrogen atom, right? So this Bose model of hydrogen atom, in which we can explain, right? So the different series, as we already seen in case of so the electromagnetic radiations which are seen in case of hydrogen, that is a Balmer series, Paschen series, bracket series, Fund series, like this, right? So according to Bose model of hydrogen atom, so there are some important points. One is an electron in a hydrogen atom can move around the nucleus in a circular or a fixed radius of energy. These parts are called as orbitals or energy levels, right? So these are the some of the important postulates, so which can be asked for 3 marks. Be careful with the question. Write the postulates of Bose model of atom. Most of the time it is repeated for your annual examination, and very simple. There are only 4 important postulates in case of Bose model of hydrogen atom. So that we'll see one by one. First one is an electron in an hydrogen atom can move around the nucleus. The electron moves around the nucleus in a circular path or in a fixed radius of energy. These paths are generally called as orbits, or these are generally called as energy levels, right? So here if I represent this one, here if I take this as a nucleus, right? So this is, I'm talking about a hydrogen atom. So in case of hydrogen atom, what happens? The center part is generally recognized as nucleus, and if you take electron, so this electron can revolve around this nucleus, right? So these electrons can revolve around this nucleus in a fixed circular path. So these are in the form of circular paths, and these circular paths are generally called as orbitals, right? So these are generally called as orbitals, or they are also generally called as energy levels. These are generally called as orbitals, or they are also called as energy levels. Remember, so in case of hydrogen spectrum, what happens? The electrons can move, or the electrons can rotate in a circular direction around the nucleus of the atom, so that circular path is generally called as orbitals, or these are also known as energy levels. That is the first postulates of Bose, right? So Bose model of atom, that is for the hydrogen atom. And second important postulate is, as long as the electron remains in the particular orbit, it does not loses or gain energy, right? And its energy remains constant, which means here if you observe there is an electron here, so this electron can jump from one energy level to another energy level, right? So it has capacity to jump from one energy level to another energy level. So if it does not jumps, its energy remains the same, right? So the electron which is present in the same orbit, right? So if you take this in the form of energy levels, here if there is an electron, so it can jump from one energy level to another energy level, right? So if it doesn't jumps from energy level to another energy level, so there is no any kind of change in energy. Whenever it jumps, its energy goes on changes. So that is the second important postulate. As long as the electron which is present in the same orbit, as long as the electron which is present in the same orbit or same energy level, it does not loses or gains any kind of energy. The energy remains the same, and its energy remains a constant, right? So it does not gains also, it does not loses energy also. That is the second important postulates of Bose atomic model of hydrogen. And the third important the postulates is, whenever the transition occurs between two stationary states that differs in the energy, the frequency of radiation absorbed or emitted can be calculated. That only I have explained, right? So if you take the nucleus, and if the electron are present in terms of orbitals, so here if you observe, right, so this electron which is present in the last orbit, when jumps to the, right, so the first orbit, then there will be a change in energy, that we can calculate how much energy has changed whenever it jumps from one energy level to another. Similarly, these orbitals can be drawn in the form of energy bands, right? So our energy level, this is zeroth energy, first energy, second energy, third energy, right? So if I take the electron here, whenever this electron jump from 0 to third, which means the electron jump from E0 to E3 energy level, so there will be a change. In energy. Right? So this energy, whatever the change in energy, can be calculated. So with the help of a frequency, that frequency is equal to delta E divided by H, right? So this change can be obtained by the frequency nu is equal to, so delta E divided by, so H, where H is the Planck's constant, right? So wherever H is there, that is the Planck's constant. Therefore delta E is equal to, so here the change in the value, that is E3 minus E0, right? So whatever the E3 minus E0 is there, so I can substitute here divided by H. By calculating this, I can get the frequency of the radiation, whatever the frequency has changed due to the jumping or movement of electron from one energy level to another energy level, that can be obtained. So that is the explanation of third postulates in case of Bose model of hydrogen atom. And the fourth one is, the electron can move only in those orbitals, right? So it cannot be present in all kind of orbitals. The electrons specifically present in a particular orbit, right? So in which its angular momentum is integral multiple of h upon 2 pi, right? So which means the electrons cannot be present in all the orbitals, right? So the electrons cannot be present in all orbitals. It will choose only that kind of orbitals, right? So the electron has capability to choose its own orbital, so whose orbital value is the integral multiples of h upon 2 pi, right? So that is integral multiples of h upon 2 pi, and that is given in the form of MEVR, right? So MEVR is equal to n into h upon 2 pi, which means the orbitals which has capability of having the angular momentum as an integral multiple of h upon 2 pi, whose value is integral multiple of h upon 2 pi, only in that condition what happens, the electron present, which means electron cannot be present in all the orbits. These electrons cannot be present in not all the orbits, it will be present in only that kind of orbit which has the value of integral multiple upon h upon 2 pi, right? So whose orbital value is the integral multiple of h upon 2 pi, only in that orbit you can see the probability of electron, right? So which means electron cannot be present in all the orbits, right? So it has a specific capacity. So those orbitals which are having the integral value of h upon 2 pi, only in that case the electron can be present, right? So that is a fourth important postulates of Bose atomic model of hydrogen, right? So once again we'll see all the four postulates. First one is an electron in an hydrogen atom can move around the nucleus in a circular path. These circular paths are called as orbits, or these are generally called as energy levels. So that is the first postulate. Second one is, as long as the electron remains in a particular orbit, it does not loses or gains energy. Its energy remains constant, which means here I have showed the electron is present in the first orbit. So unless it jumps from one orbit to second orbit to third orbit like that, so its energy does not changes. That will be the constant value. There will be no change in energy whenever it remains in the same state, or it is generally called as stationary state. And the third important postulate is, so whenever the transition occurs, right? So whenever the electron changes its energy level from first to second, second to third, or first to third, we can calculate how much energy is changed. That is with the help of a frequency formula. That is, frequency is equal to delta E divided by H, where delta E represents the change in energy. That is E2 minus E1. If the electron jump from 1 to 2, so you can calculate it from E2 minus E1. So therefore divided by H. H is the Planck's constant. So that value gives the change in energy during the movement of electron or transition of electron from one energy level to another energy level, that can be calculated. And the fourth important postulates of Bohr's atomic model is, so not all the electrons the electrons cannot be present in all the orbits. So it will choose the specific orbits whose the angular momentum is the value of integral multiple of h upon 2 pi, which means the orbitals. So the orbitals which has the value of h upon 2 pi, only in that condition the electron can be present. Otherwise the electron will not present in all the different orbitals of or different energy levels also. Right, so this can be asked for 3 marks. Most of the time it is repeated. Don't neglect and practice these 4 important postulates. Right? And there are some important limitations of Bose model, limitations or restrictions for the Bose model. So one thing is, Bose model failed to account for the finer details of the hydrogen spectrum. Right, so it is just gave the outer explanation about the hydrogen atom, but the complete explanation of hydrogen atom does not give any kind of clear idea how this hydrogen atom can be explained, right? So that is the first important limitation is, so it cannot explain all the concept, or it cannot give any kind of detailed explanation about the hydrogen atom. It only gave about the orbitals, and it only gave about the strength of or energy of the orbitals, or it only gave the explanation about the change in energy whenever the electron can jump from one orbital to another orbit. Other than this, there was no any kind of detailed or the accurate explanation about some of the other concepts in case of hydrogen spectrum. That is one of the drawback, or you can call it as limitations of Bose atomic model. Right? Second one is, the Bose atomic model was unable to explain the spectrum of atom containing more than one electron, which means the Bose atomic model can be only explained for the hydrogen atom, because hydrogen consists of only one electron, right? So if you take the hydrogen, the atom has a nucleus and only one electron revolve around because its atomic number is 1. Hydrogen has the atomic number is 1. So this Bose, right? So this Bose atomic model is explained only for the hydrogen atom, but not other elements like carbon, oxygen and nitrogen, sulfur, right? Like this for another atom, that is for another element, so that atomic model does not satisfy or does not explain for the another elements or the another atoms. Therefore it is only restricted for the hydrogen because it consists of only one electron, right? So Bose model, according to Bose model, so it can explain the concept or atomic model only for hydrogen, but it cannot be explained for all the other different elements also, right? So that is about the Bose model and limitations of Bose model. Okay, once we'll go through whatever we have studied in today's classes, that is spectrum. When the light radiations pass through prism, it splits into different colors or several bands that we have seen. And even in case of spectrum also, right? So there are two different kinds of spectrum. One is continuous spectrum, second one is line spectrum, and we have seen what is the difference between emission spectrum and absorption spectrum also. And we have defined spectroscopy also. It's a branch of chemistry which deals with the study of the emission as well as the absorption of radiations or the spectral lines, that is generally defined as spectrum also. And also we have seen the spectral lines which can be present in case of atomic hydrogen, or so the hydrogen atom. So that is different series, Lehman series, Balmer series, Paschen series, bracket series as well as Fund series. And also we have seen so in which spectral region so these different kinds of series can be obtained. Remember, Lehman series is obtained in case of ultraviolet radiations, and Balmer series generally obtained in case of this visible region, and all the other three, Paschen series, bracket series and Fund series, are obtained in case of infrared radiations, right? So and also we have seen the dual nature of light. Along with that, we have also seen the Rydberg equation, and most important thing is Bose model of hydrogen atom. There are 4 important postulates of Bose model of hydrogen that is definitely asked for your annual examination. Along with that, we have seen some of the limitations of Bose atomic model of hydrogen, right? So that's all from the today's classes. We'll continue in the next class. Thank you.